In this video, we're going to keep adding knowledge to your knowledge base about value versus reference, shallow and deep cloning. To start this video, I would like to take the example we had in the last video and extend it a bit. So in this case, we're going to create a new object, again called person, but this time let's add a first name of, for example, Emma, and then Emma is going to have a car. A car needs to have a brand, right? So let's say that Emma is driving a BMW. Then the color of that car is going to be blue. And finally, the number of wheels on all cars is 4, but let's also have that in there. Now, let's try creating a copy of that object in one of the ways we learned in the previous lecture. For example, we can use the spread operator. Const new person is going to be equal to a new object, and then we spread it, ... person. That's it. We've learned that this removes the reference from the original object, right? So let's try changing the newly created object. For example, new person dot first name is going to be equal to Mia. And this time we expect only the new person to change, not the person. So if we console log both the person and also the other person or the new person, let's see what the result is. As you can see, the first name is Emma, it remained Emma, and in here we changed it to Mia, and everything worked. As we learned, if we use the spread operator, the reference to the initial object gets deleted. Therefore, we can change the new object without having to worry. Oh, if only it were that simple. Let's see what would happen if we try changing the properties of Mia's car. So in here, if I try doing something like new person, and then dot car, and then dot color to be equal to red. If we add this, just to make this a bit easier to see, I'm going to immediately console log the car for both persons. If we do that, take a look. The color of Emma's car is red, as well as the color of Mia's car. They're both red, although we changed only the color of Mia's car. How did that happen? Well, we only removed the reference from the outer object, this one here, the person one. But notice how car is also an object. It also has its own reference, and the same rules apply. If we want a real copy, we need to remove a reference from the inner object as well. We could do that by spreading the properties of an inner object. In here, we can add a comma and then add a car property. Now that car is going to be equal to a newly created object where we're going to spread ... person ... car. This makes sure that we also remove the reference from this object right here and not only the big one. Now if we save that, everything should work as we anticipated. This one wasn't changed, while this one was changed. So we fixed the issue, that's great. But this only works for 2 levels of depth. First level is when we are inside of the person object, for example the first name Emma. And the second level is once we are inside of the car object, so that's these 3 properties. But if we had more nested objects, we'd need to spread everything, and that's not a solution. When we have deeply nested objects, we need to create a deep clone. For an object to be a deep clone, it needs to destroy all the references. There are 2 methods that are going to make this extremely easy for us. First one is called JSON.stringify, and the second one is called JSON.parse. Now, let's see them in action. We can use the same person object we declared above, but I'm going to remove this thing. First, we're going to use the JSON.stringify method. The JSON.stringify method converts a JavaScript object or any value to a string. All the references are destroyed. So we can do something like this. Const stringified person is going to be equal to JSON.stringify, and in there we can pass the person. Now let's console log the stringified person. If we save this, the thing that we get back is a string. that isn't at all valuable to us. So how can we turn it back to an object again? We can do that by using a JSON parse method. Const new person is going to be equal to json.parse. And then in there, we can pass in that stringified person, just like so. Now, take a look at what we get back. This is an object, but an object that is a deep clone of the person object. The JSON parse method parses a string, and it constructed the JavaScript value or an object contained in the string. Before we start testing it out, there's one simple tweak we can make. We can do this in one line. We don't have to create this external variable called stringified person. We can just take the value of it and then paste it immediately right here. Now what's happening is that we are first stringifying a person, and then we are immediately parsing that, and then we get a new person. If we save it, you can see we get our object back. Let's prove that all of the references are indeed deleted and that the new person is indeed a deep clone. We can do the same thing we did before. New person dot first name, and we can set that to be equal to Mia, and also new person dot car dot color to be equal to the color of red. Now, if we console log the new person and also the person, let's see. Okay, in here we have Emma, and Emma has a car, and the color of the car is blue, so nothing was changed. And in here we have Mia. Mia has a car that has a color of red. That's it. You just mastered one of the hardest topics in the whole of JavaScript. If you're still a bit confused, that's completely normal. I'd suggest rewatching this section. Take it slow. Mastery takes time.